Hi, Mr. Mac, and we're looking at momentum. Most of you will have seen this. It's called Newton's Cradle. You can get them in toy shops and gift shops, but also in science stores. Bit of an executive toy, but they do show elastic collisions. So let me demonstrate with just one of them. I pull it out, and you can see quite clearly that one appears to come to a complete standstill while the other one goes away and then comes back and repeats itself. We can have lots of fun with Newton's Cradle, spend hours and hours of time, but the most important thing is to think about the mass of each ball and the elastic collision. So here I've lifted up 3 balls, and 3, after the collision, end up being pushed away. When we look at momentum, we're looking at different types of collisions. Collision just means where 2 masses come in contact with each other. And what happens after that? One of the key principles in momentum is that momentum is always conserved. In other words, if you add up the mass times the velocity for each of the elements before the collision, that will equal the total of the mass times velocity for each of the components after the collision. I have here some toy cars, model cars, the dark blue one and the light blue one. They each have a mass in themselves of 50 grams. I've put a 50-gram mass in each, doubling that to make each one 100. On the front of the light blue one, there's a spring. So the first thing we'll have a look at is elastic collision. And like Newton's cradle, one stays still, the other goes off at the same velocity. If I doubled the mass, then the velocity of the second one would be higher. In fact, double. Let's turn them around. I've got a bit of Velcro on the end of the dark blue one, and the other side of the Velcro is on the light blue car, and this is going to simulate an inelastic collision. And you'll notice straight away that the velocity was halved. It has come to a stop because of friction. These aren't very good toy cars, but they work nonetheless. Momentum before the collision equals momentum after the collision. The difference is with an elastic collision, like Newton's cradle, and where there's a spring, then we find that kinetic energy before the collision equals kinetic energy after the collision. But in a collision where it's inelastic, we've got the Velcro, even though momentum is conserved before and after, kinetic energy is not conserved. And that kinetic energy goes into, well, we've seen this cars in accidents, the crumple zone at the front of a car. So once more, here is an inelastic collision where momentum is conserved, but kinetic energy is not conserved. And that's momentum. I'm Mr. Mac. Thank you for listening.